if dk is this determinant where you have first row as 1, 2k and 2k minus 1, and then second and third row, they have terms containing n. If summation dk k from 1 to n, this is 96, then we have to find the value of n. Now, in case of determinant, we learned one important property that in a determinant, if any one row or any one column is sum of two elements, right? For example, let us say first row is a1 plus b1, then you have a2 plus b2, and here you have a3 plus b3. This is our first row. And the second row, this is, let us say, c1, c2, c3. And the third row, this is d1, d2, and d3. If I have this determinant where any one row is sum of two elements and the other two row, they have c and d. So this you can break as sum of two determinants, right? And this thing is true whether you have two elements in any one row or any one column, provided the other two rows or other two columns, they are same, right? So here you can write this as sum of two determinants. For first determinant, the first row will be a1, a2, a3. The second and third row, that will be same, right? Second row c1, c2, c3, and then d1, d2, d3. This will be one of those two determinants. And for the second determinant, you can take the second element only. That means here you can take for first determinant, the first row was a1, a2, a3. And for the second determinant, the first row will be b1, b2, b3. Then here you have c1, c2, c3. And then we have d1, d2, d3. Now, this is one important property that we are going to use in this problem. If any one row or any one column is sum of two elements, then you can split that determinant as sum of two determinants. Uh, the second and third row you will keep same, and the first row will contain these three elements a1, a2, a3. That will be the first row of this first determinant. And the first row of second determinant, this will be b1, b2, b3. Now, this property we can use in reverse manner also. That means if I have two determinant and for both of those determinants, second and third row are same, then basically we can add the corresponding elements of first row, and this we can do column wise also. Now, here if you notice, dk and k is only present in first row. So if I calculate d1, the second and third row will be same, right? They will have n square plus n plus 2 and so on, and only the first row will change, right? In d1 you'll have 1, 2, and then 2 minus 1, that is 1. In d2 in place of k will have 2 and so on. So that means here if I want to add all of those determinants, we can just add the corresponding element of first row, which means that this sigma notation we can take inside this determinant along the first row. So if I need summation dk, now we can write this thing as summation dk. This is given as 96. So this means we can take that sigma notation inside the determinant, and we can write this as sigma 1 n and n. Similarly, sigma 2k, and then we have n square plus n plus 2, and here we have n square plus n, and finally we have sigma 2k minus 1, and then you have n square plus n plus 2. So this will be sigma dk, right? And obviously k is from 1 to n, and now this sum, this is given as 96. So this is one important property, but remember that this variable k, this must be along any one row or any one column. Then only we can take this sigma notation inside, right? So we can take that sigma inside the first row, and now we have to expand this determinant. First, we have to simplify those terms. So sigma 1, this will be nothing but n. Sigma 2k, 2 we can take outside, n into n plus 1 by 2. So this is nothing but n square plus n. And sigma 2k minus 1, this is sum of first n odd natural numbers. And we know the standard formula is n square, right? Sum of first n odd natural number is n square. Similarly, here we have n square plus n plus 2, n square, n square plus n. I mean, now this is a standard problem of properties of determinant. The important concept was that sigma notation, if we have k only in one row or one column, then we can take that sigma notation inside the determinant. Now let us create two zeros using row and column operation. So here we can perform this operation that in place of R1, we can do R1 minus R2, right? That will give us 1, 0. And similarly, in place of R2, we can do R2 minus R3, right? So if we perform this operation, then in place of first row, R1 is R1 minus R2. So this will become 0. Here we'll get minus 2. This will also become 0. R2 is R2 minus R3. So again 0. Here we'll get 2. And this will be minus n plus 2. Here we'll get n. And because we have two zeros here, these two elements will not contribute to determinant. Right? If I have two zeros, if these two numbers are 0, so then these two elements, they are not going to contribute to the equation of determinant. So now this will be n. I'm expanding along the uh, first column. So n into these two minus the other two elements. So 2 into n plus 2. This is 96. From here you can see that n into n plus 2 and 96 by 2 is 48. On left hand side we have two integers and difference between those two is 2. So 48 we can write as 6 into 8. And then directly you can see because n is positive integer, n is number of terms, so n must be 6, right? By creating quality also you can solve, but I mean directly you can see that using hidden trial that n is 6. And therefore, the correct answer, this was integer type problem, so the correct answer for this problem will be 6, right? So this was again one important concept from determinant, that if these two rows are um, same in the two determinants, then basically we can add the corresponding element of first row, and which implies that, I mean, if we have more than two determinants, then also we can add the corresponding element of first row. So sigma notation we can take inside the sign of determinant, and then after that, using a standard properties of determinant, we got n as 6. So that is the correct answer for this problem. Let A be this matrix. In first column, we have 2, 4, 6. Then in second column, we have these unknowns P. And then in third column, we have Q with some constant also. Now, if determinant of adjoint of 3A, this is 2 raised to m into 3 raised to n, where m and n are natural numbers, then we have to find the value of m plus n. Now, this is not a difficult problem. I mean, one can very easily calculate the determinant of matrix A, and then using properties of adjoint and inverse, you can find this determinant of adjoint of 3A, and from there you can calculate m and n. But in this problem, there is one shortcut method, that because this determinant, this is given determinant of adjoint of 3A, this is given in terms of 2 raised to m, 3 raised to n. There is no p or q in this equation, right? M and n, these two natural numbers, and determinant of adjoint of 3a, this is 2 raised to something multiplied by 3 raised to something. So if there is no p or q for determinant of adjoint of 3a, so that will mean that determinant of matrix A, this must be independent of P and Q. Right? It is not difficult to show that result. I mean, if you want to get rid of P, then in place of C2, you can write C2 minus, and then 2, 4, 6, and here we have 1, 2, 3. So basically half of this column, and that multiplied by P into C1. So that will get rid of these three elements, these three terms P, 2P and 3P. Similarly, you can get rid of Q also and P from this third column. But here, because the determinant of adjoint of 3A, this is independent of P and Q. The determinant of matrix A, this must be also independent of P and Q. So you can take any value of P and Q, and we should get the same value of determinant of A. So here what we'll do is, in place of P and Q, we can take 0, right? If I take P as 0 and Q as 0, then determinant of matrix A, this will be 2, 4, 6. Then we have 2, 6, 12. And then third column will be 2, 8, and then 20, right? So, I mean, there is no need to show that the determinant of this matrix is independent of PQ. It has to be independent of PQ because otherwise, this thing will not be a constant, right? This will not become 2 raised to m. I mean, it will include P and Q also. And now from here, we can very easily calculate determinant of this one. In place of C1, if we want, we can create two zeros. So in place of C1, we can write C1 minus C2. And in place of C2, we can write C2 minus C3. So in that way, we can create two zeros in same row, and then we can expand along that particular row, right? So in place of C1, if I do C1 minus C2, then 2 minus 2, that will be 0. Then here we'll get minus 2 minus 6. Again 0, minus 2 minus 8. And then we have 2, 8 and 20. And now we can expand this determinant along the first row. So this will give us 2 into and then 16 minus 12. So 16 minus 12, that will be 4. That means determinant of matrix A, this is nothing but A, right? That is determinant of matrix A. And now we need to find this thing. We have to find determinant of adjoint of 3A, right? Now we know that this thing will be nothing but determinant of 3A, and this raised to n minus 1, n is 3, so n minus 1 will be 2. And we have adjoint twice here, right? Adjoint of 3A. So that means another 2 in exponent, right? Determinant of 3A raised to n minus 1 raised to k. N is the order of matrix and k is the number of times we have adjoint. So because we have adjoint 2 times, this raised to 2. So this becomes 3 into, and then uh, this we can, if we want to take this 3 outside, remember we have to take 3 cube outside. So 3 cube into determinant of A, and this raised to 4. Now 3 raised to 3 cube raised to 4, so that will be 3 raised to 12. And determinant of A, this was nothing but 8. 8 is 2 cube, this raised to 4. So ultimately this will become 3 raised to 12 into 2 raised to 12. That is determinant of adjoint of 3A. So clearly you can see that M is, if I compare with this one, then 3 raised to 12, 2 raised to 12. We needed M plus N. So clearly M is 12, N is also 12. So that means M plus N, this must be 24. So the correct answer for this problem will be option C. Right? This was not a difficult problem, but there was one important concept that if you apply this logic, that because determinant of adjoint of 3A, this is independent of P and Q. So determinant of this matrix A, that must also be independent of P and Q, and therefore in place of P and Q we can take 0, and then in few lines we can get determinant of matrix A, and then after that we can use properties of adjoint. Adjoint of 3A, determinant of adjoint of 3A. So this will be determinant of 3A raised to n minus 1, and this raised to k. N is the order of matrix and k is the number of times we have adjoint. So from there finally we got 3 raised to 12, 2 raised to 12, m plus n will be 24, and therefore the correct answer for this problem is option C. Let S be the set containing all 3 cross 3 matrices whose entries are from this set minus 1, 0 and plus 1. We have to find the total number of matrices A belonging to this set S such that sum of diagonal elements or the trace of this matrix A transpose into A, this is 6. So basically we have to find the number of 3 cross 3 matrices whose each element is either minus 1 or 0 or plus 1, and the sum of diagonal elements or the trace of this matrix A into A transpose, this is 6. Now before we attempt this problem, there is one standard formula for writing trace of any square matrix, right? There is one general result that you must be familiar with. I'll take an example of 2 cross 2 matrix to explain the idea, but the result is valid for any general n cross n matrix, right? So let us say if I have some matrix A, B, C and D, and we need to find A into A transpose, right? Let us calculate A into A transpose in the same line. So our matrix A is A, B, C, D, and therefore the transpose of this matrix will be another square matrix in which rows are converted into columns. So the first row will become first column and the second row will become second column. That means here we have A, B, C and D, right? A was this first matrix, so this is matrix A into A transpose. Now Here you can see that if I multiply these two matrices, then result will be another 2 cross 2 matrix, right? And in order to find the element of first row, first column, we have to multiply first row with first column. So here we'll get a square plus b square. First row, second column, we do not need because we are only interested in the trace of this matrix. Similarly, this entry also we do not need. Second row, second column, this will give us c square plus d square, right? So this is our matrix A into A transpose. Now, if I ask what is the trace of this matrix A into A transpose, clearly you can see that trace will be sum of diagonal elements. So A square plus B square plus C square plus D square, right? That will be the trace of this matrix A into A transpose or A transpose into A, right? Trace of both of these matrices, whether it is A into A transpose or A transpose into A, you will get the same result. This will be A square plus B square plus C square plus D square. Now notice that A, B, C, D were nothing but the elements of this 2 cross 2 matrix, right? So this is one very important result, that for any square matrix, trace of A into A transpose is nothing but sum of square of all the elements in that matrix. Here I have taken example of 2 cross 2 matrix, but the result is valid for 3 cross 3 matrix also, any n cross n matrix, right? So let us say if we have this 3 cross 3 matrix in which elements are first row is, let us say, a1, a2, a3, and similarly we have two other row because the given example is of 3 cross 3 matrix, right? To explain the idea, I have taken a 2 cross 2 matrix. From there we got this result, that trace of A transpose into A or A into A transpose, that is sum of square of all the elements in the matrix. Now let us say matrix A is A1, A2, A3. We have 3 cross 3 matrix. Then we have A4, A5, A6, and finally we have A7, A8, and A9. These are the 9 elements of matrix A. Now, it is given that trace of A into A transpose or A transpose into A, this is 6, right? So, what is the meaning of that result? That sum of square of all the elements in this matrix, that must be 6, which means A1 square plus A2 square plus A3 square, and in this manner up to A9 square, this must be 6. And here it is given that the different elements of this set, they are either -1 or 0 or +1, right? So now we have total 9 variables, A1, A2, A3 up to A9. Sum of their square, this is 6. And each variable can take only these three values. Either you can take A1 as -1 or 0 or +1. Same thing for A2, A3 up to A9, right? So here if I have to create a sum of 6, that means any 3 out of these 9 variables must be 0, right? Here each term will be either 0 or +1, right? Because if I take A2 as 0, A2 square will be 0. If I take A2 as -1 or +1, then A2 square will be +1. So total 9 terms are there, and value of each term will be either 0 or 1. If I take that element as 0, AI square will become 0. And if I take either +1 or -1, then its square will be +1 only, right? So here, if we need number of matrices satisfying this condition, then out of these 9 variables, select any 3 variable, right? Select any 3 of these 9 AI, and for that we have only one option. We have to make those variables 0, right? For example, let us say we have selected A1, A2, and A3. So we'll make these 3 variables 0. And then for remaining 6 variables, we have two options, right? Either you can take them as +1 or -1, because whether you take +1 or -1, the square of that number will be 1 only. So therefore, number of matrices, this will be 9C3 into 1. And then for remaining 6 variables, we have two options each. So for remaining 6 variable, using multiplication rule, 2 into 2 into 2, 6 times. So basically the answer will be 9C3 into 2 raised to 6. And after calculation, you will get this number as 5376. This calculation you can do on your own. So that will be the value of 9C3 into 2 raised to 6. So therefore, that is the correct answer for this problem. right? So in this problem, the important concept was that trace of A into A transpose or A transpose into A, that is nothing but sum of a square of all the elements in that matrix. So from there we got this result that sum of a square of all the elements in this matrix, that must be 6, and therefore out of these 9 variables, make any 3 variables 0, and for remaining 6 variables we have 2 options each. So the correct answer for this problem is 5376. Let A be a symmetric matrix of order 2, means A is a 2 cross 2 symmetric matrix with integer entries. So each entry of that matrix must be some integer. It is given that sum of diagonal elements of A square is 1. Sum of diagonal elements means trace of the matrix. So for matrix A square, trace is 1. Then we have to find the number of possible matrices. Now in this problem, the keywords are that A is a 2 cross 2 symmetric matrix with integer entries. Now remember that in case of symmetric matrix, the definition of symmetric matrix is that A transpose, this is same as A. And another way of saying the same thing will be that element in ith row, jth column, this is same as element in jth row, ith column. That means the matrix is symmetric about its principal diagonal, right? So here, for example, if I have to take a 2 cross 2 symmetric matrix, first we'll start with a general 2 cross 2 symmetric matrix, and the trace of that matrix will be, trace of A square will be 1. So from there, we'll try to find an equation in variables, and then we'll see what are the different integral values of those variables which will satisfy that equation. So in case of symmetric matrix, you can have anything on diagonal, but these two elements must be same, right? Element in first row, second column. This must be same as element of second row, first column. The matrix must be symmetric about its principal diagonal. So let us say this is matrix A. Now, if this one is matrix A, then A square will be matrix A into matrix A, right? A square means A into A. So we'll write the same matrix again, and then we'll see what should be the trace of this matrix or some of the diagonal elements of this matrix, right? So sum of diagonal elements means when for A square, the element of first row, first column will be first row multiplied by this first column. Remember, it is given that trace of A square, this is 1. Now trace of A square means first row, first column. This will give us A square plus C square, right? This will be the element of first row, first column of A square. And similarly, element of second row, second column, this will be C square plus B square, right? And this has to be 1. We are not calculating the element of first row, second column or second row, first column, because trace means sum of diagonal elements only. Now from here we are getting A square plus B square plus 2 square. This must be 1. Now ABC are integer, and A square plus B square plus 2C square, this must be 1. So then we have to see what are the different possible values of A, B, C. Now as these numbers are integer, for this variable C, we have only one option, and that option is C must be 0. Because if you take any other value of C, then you cannot make this sum 1, right? If I take C as 1 or minus 1, then this term itself will be 2, and then we have other positive term, whereas the right hand side is 1 only. So for C there is no option, the value of C must be 0, and if C is 0, then the equation becomes A square plus B square, this equals to 1. Now, what are the different integral solution of this equation? So one possibility is that you can take A as plus minus 1 and you can take B as 0, or another possibility will be that you can take A as 0 and B as plus minus 1. These are the only two possibilities. In fact, four possibility, plus minus 1 and 0. So one matrix will, I mean, in all of those matrices, the value of C will be 0. So there will be two matrices for which C is 0, B is 0, and A is either plus 1 or minus 1. And there will be other two matrices for which A is 0, C is 0, and B is plus 1 or minus 1, right? So clearly you can see that there will be four such matrices with integral entries, right? 4 2 cross 2 symmetric matrices with integral entries for which trace of a square, that will be 1, right? So therefore, the correct answer for this problem must be second option. So, I mean, this was not difficult problem. All we had to do was start with a general 2 cross 2 symmetric matrix. And in case of symmetric matrix, element in ith row, jth column, this must be same as element of jth row, ith column. So from there we got a square plus b square plus 2c square as 1. And now value of c must be 0. Then the equation was a square plus b square is 1, which means a is plus minus 1, b is 0, or a is 0 and b is plus minus 1. So total there are 4 such matrices, and therefore the correct answer for this problem is option B. We have this 3 cross 3 matrix A, and in this matrix A, on diagonal we have 1, and the elements which are below the diagonal, they are 0. That means it is upper triangular matrix, right? In case of upper triangular matrix, the elements below the principal diagonal, they are 0, and there are two unknowns A and B, right? The other three entries, they are A and B. If for some n belonging to this natural number n, matrix A raised to n is this matrix where on diagonal we have 1 1 1, and the elements above the diagonal, they are these three elements, and elements below the diagonal, they are 0. Then we have to find the value of n plus a plus b. So basically here we have to calculate this matrix A raised to n in terms of n, and then by comparing the corresponding elements, we need to get the value of n, a and b. Now in this problem, there is one important concept, that because for matrix A, the element below the principal diagonal, they are 0, and on diagonal we have 1. So we can write this matrix A as identity matrix plus some other matrix B, right? And if I break this matrix A as I plus B, then clearly you can see that matrix B will be I means 1 1 on 1 1 1 on diagonal. So the other matrix B, this will be nothing but will have 0 on diagonal. The elements below the principal diagonal, that will be also 0, and you will get only 3 elements above the diagonal which are non-zero elements. And then if you calculate b square and higher power of that matrix, then after a point you will get null matrix, because we are writing matrix A as I plus B. So this 1 1 1 on diagonal, that will be taken care by this identity matrix. So here you will get A and B, and these elements are still 0. So this is our matrix B. And if I have to calculate A raised to n, then we can calculate I plus B raised to n. And we can expand that using binomial theorem, because I and B, these two are commutative matrix, right? Now, if this is matrix B, then let us try to calculate B square. For finding B square, we can multiply this matrix B with B, right? B square means matrix B into B. So here b square will get again 0 0 0 on diagonal. The three elements below the diagonal, they are also 0, and then we have a and b. Now let us see what we are getting for b square, right? So because this is one important concept, there are few PYQ where you will get these type of matrices. Upper triangular matrix where elements below the principal diagonal, they are 0, and we have 1 on diagonal. Now here if you calculate b square, first row first column, that will give us 0, first row second column 0, first row third column, so that will give us 0, then AB, and then again 0. Second row first column 0, second row second column will be 0, second row third column, that is still 0, third row is completely 0, so these three elements will become 0. So this is our matrix B square, and you can verify on your own that if you calculate B cube, that means B square into B, so that will give you null matrix, right? If I calculate B cube, this will be null matrix, and the moment B cube is null matrix, any large power, any higher power of that, B raised to 4, B raised to 5, B raised to 6, all of these matrices, they will be null matrix only. So that means now if I have to calculate A raised to n, we can use the binomial theorem for that one. So A raised to n, this we can write as I plus B raised to n, because I and B, these two are commutative matrices. So therefore we can use binomial expansion. So this will become I raised to n NC1 into B, and then NC2 means n into n minus 1 by 2, this multiplied by B square. And because PQ is null matrix, so after that B raised to 4, B raised to 5, all of them are null matrices only, right? So this is our matrix A raised to n. A raised to n, this will be I plus n into B plus n into B square. And the given matrix A raised to n, let me write that matrix here and then we can compare the corresponding elements. So for A raised to n, this was given as A raised to n, right? This was our matrix A raised to n. We had 1 on diagonal and then we have 48, 2, 1, 6, 0 and then 96. So now let us try equating the corresponding elements. That will give us equation in A, B and n, and by solving those equations we can get the value of A, B and n. So A raised to n is this matrix and A raised to n is I plus n into B, n minus 1 by 2 into B square. So if I equate the corresponding elements, right, this was our matrix B. In matrix B, we had A and B. This was B. And for B square, we have AB here, right? This is our matrix B square. And in matrix B, we have these three elements A and B. So 1, 1, 1, that will take care of this identity, that will be taken care by this identity matrix. Now, element in first row, second column, that is 48. So therefore, one of the equations will be 48 equals to, and in second row, first column, sorry, first row, second column, in B square we have 0, and in matrix B we have n. So n into B, and that plus this multiplied by 0. So n into B, and here we have A. So this means 48 is nothing but n into A. This we are getting by comparing the element in first row, second column of A raised to n from here given matrix and from this right hand side. So this is one equation. Similarly, element in second row, third column, this is 96. And on right hand side, the element in second row, third column, that will be n into B. So this is another equation, right? N into A is 48, n into B, this is 96. And finally, element in first row, third column, this is 2160. And from right hand side, we'll get n into B, that means n into A, right? N into matrix B, and in matrix B, we have A here. And that multiplied by n into n minus 1 by 2, B square. And for B square, the corresponding element is AB. So these are the three equations that we have, right? One equation, NA is 48, other equation NB is 48, 96, and then this is the third equation. Now after this, it is not difficult to solve these three equations. You can substitute NA as 48 in place of n into B, you can write 96, and then you can solve these three equations. So once you solve these three equations, you will find that the value of A, this will be 4, and because we need this value n plus A plus B, so I'll directly write the answer after this. When the calculation is not difficult, just substitute these values and then you can get the answer. NA is 48 and then NA 48, and in place of B you can write 96 by n. So then first you will get the value of n. N will be 12. Substitute that value of n in first equation, then you will get A as 4, and then substitute that value n again in second equation, you will get B as 8. So n plus A plus B, that will be 12 plus 4 plus 8. So 12 plus 12, that is 24. So that is the correct answer for this problem. In this problem, the important concept was to write this matrix uh, A as I plus B, where I is identity matrix, and then this matrix B is 0 on diagonal, 0 below the diagonal, and then these three entries A and B. So once you calculate B square, you will get AB, and B cube will become null matrix. And the moment you have null matrix, any higher power of that matrix, because if BQ is null matrix, B raised to 4 is nothing but B cube into B. B raised to 5 will be B cube into B square. So all of these matrices will become null matrix. And because I and B, these two are commutative matrix, so here you can apply that binomial expansion. So finally, A raised to n, that was I plus n into B, n into n minus 1 by 2 into B square. By comparing the corresponding elements, we got these three equations. And after solving this equation, you will get n 12, a and b as 4 and 8, and therefore n plus a plus b, that will be 24, and that is the correct answer for this problem. Let A be this 3 cross 3 matrix, B be another matrix, A minus I, where I is 3 cross 3 identity matrix. Omega is complex cube root of unity, minus 1 plus root 3 iota by 2. Then we have to find the number of elements in this set n. N is first 100 natural number such that A raised to n plus omega B raised to n, this is A plus B. So first basically we need to identify the type of matrix that we have here, right? A is a given matrix. So first let us try to find which type of matrix is this matrix A. Then B is A minus I. Omega is complex cube root of unity. So first, in order to identify the type of matrix, let us calculate A square, right? If we calculate A square, if we get A square as identity matrix, that means matrix is involuntary matrix. If I get A square as matrix A, then it means matrix is idempotent matrix. So first let us calculate A square so that we can get some idea that how to proceed in this problem. So for calculating A square, we have to multiply matrix A with A. So here we have 2 minus 1 minus 1, then we have 1 0 minus 1, and then we have 1 minus 1 0. This is matrix A, and A square means matrix A into matrix A. So we have to multiply the matrix with itself, right? So again, I'll repeat the same matrix. We have 2, then minus 1 minus 1, 1 0 minus 1, and then 1 minus 1 0. Now, if you multiply these two matrices, you can do the multiplication on your own. When you multiply these two matrices, you will get the same matrix A, right? If you multiply first row, first column, then we are getting 2 minus 1, 4 minus 1 minus 1, so that is 2. So you will get this element. First row, second column, that will give you minus 1 and so on. So this multiplication you can do on your own. Once you calculate A square, you will find that A square, this is same as matrix A. And if A square is matrix A, that means the given matrix is idempotent matrix, right? In case of idempotent matrix, A square is matrix A. And if A square is matrix A, then any power of this matrix, right, A raised to n, this will be always A. This is one property of idempotent matrix, that if A square is A, then A raised to n, this is also A. Because, I mean, you can very easily see this one, that if A square is A, if I have to calculate A cube will be A into A square, and A square is A, so this will again become A square, and A square was same as matrix A. So in similar manner, you can show that any power of this matrix A, that will be matrix A only, right? So now this equation, A raised to n plus omega B raised to n, and on right hand side, this is A plus B. So if matrix A is idempotent matrix, then A raised to n, this is nothing but matrix A. So basically we have omega B raised to n, and this is A plus B. Matrix A you can cancel from both sides. So then finally we have this relation, that omega raised to n into B raised to n, this should be matrix B. So this is the relation that we have to satisfy. Because matrix A was idempotent, so A raised to n, that is matrix A only. So now the equation that we have is omega raised to n into B raised to n, and this must be matrix B. So for that, matrix B is given. Matrix B is A minus I. So now let us try to calculate different powers of B. Also from this one equation, you can write two equations. One is that omega raised to n, this must be 1, and B raised to n, this must be B, right? Because omega is complex cube root of unity. So if I equate the coefficient of this matrix, omega raised to n must be 1. So if omega raised to n, this is 1, this will imply that n must be multiple of 3, right? Omega cube is 1. So omega raised to 3 or omega raised to 6, all of those numbers will be 1 only. And n is set of first 100 natural numbers. So that means n will be either 3 or 6 or 9 or 12. N will be multiple of 3 only. Right? Remember, we need to satisfy both of these conditions. So first condition will be satisfied if n is multiple of 3. And now we have to focus on the second one, that how we can make b raised to n as b. So for that, it is given that matrix B is A minus I, right? This result is given that matrix B, this is matrix A minus I. So let us calculate B square first, right? If this is matrix B, B square will be A minus I square. And because A and I, these two are commutative matrix, so therefore here we can use A plus B whole square formula, because I into A, that will be same as A into I. So this will become A square plus I square and then minus 2I. Now because A square is same as A, since matrix A was idempotent matrix, so this we can write as I, and then A minus 2A, that will be minus A. Now remember, matrix B was A minus I, and B square we are getting I minus A. So this will mean that B square, this is nothing but negative of matrix B, right? B square is uh, I minus A, and matrix B, this was A minus I. So this means B square, this is minus B. Now how to use this relation? So if B square is minus B, just multiply again by matrix B, and then we have B cube equals to minus B square. And what is minus B square? Minus B square, this is same as matrix B. So that means B raised to 3, this will be matrix B. Now this is another important relation, that if BQ is matrix B will be periodic matrix, right? In case of periodic matrix, A raised to n plus 1 is same as matrix n. So if B cube, this is matrix B, this will imply that matrix B is periodic matrix. And what is the period of this matrix? So period will be nothing but 2, right? I mean, for periodic matrix, the definition is A raised to n plus 1 is matrix A. Then we have a periodic matrix, n is period. So here this 3 you can write as 2 plus 1. So that means we have a periodic matrix with period 2. And that will imply that matrix B, this is same as B cube. This will be same as B raised to 5, right? Just keep on adding 2 in this and you will get the same matrix. And again, it is not difficult to show this result, right? If I have to show that B raised to 5 is same as B. So B raised to 5, this you can write as B cube into B square, right? B raised to 5 will be B cube into B square. And what is B cube? B cube is matrix B. So this becomes B cube. And this was same as matrix B. Right? Using this result, once we have the relation that B cube is same as matrix B, we have a periodic matrix with period 2. And just keep on adding 2 in exponent, we'll get the same matrix. So B raised to 3, 5 or 7 or B raised to 9, all of these matrices will be same, right, up to B raised to 99. So if I have to satisfy this second condition that B raised to n, this should be same as matrix B. So then it will imply that n must be any one of these number. N has to be either 1 or 3 or 5 or 7 or 9 up to 99. Right, now let us call this 1. If omega raised to n is 1, then n must be multiple of 3. And if b raised to n, this is same as matrix B, then n must be all of these odd natural numbers. So now, because we have to satisfy both the conditions, we need to take intersection of 1 and 2. So if I take intersection of 1 and 2, then n will be this set, right? N will be the common values 3, 6, 9, 12 and so on, 1, 3, 5, 7 and so on. So the common values are 3, then next number will be 9, right? After that 15, then we have 21 and so on, right? We'll get multiples of 6 plus 3. So the last common term, this will be 99. And now we need to find how many common terms are there. I mean, how many terms are there in this set, right? So clearly you can see that in this set, the total number of terms will be when you can calculate this one, you can using the formula of AP, or directly also you can see this result, that if I remove 3 and then divide everything by 6, then we'll get 96 by 6, that is 16 plus 1 more term. So total number of term in this series is 17. So that will be the correct answer for this problem. So I'll quickly summarize what we have done in this question. First, we have calculated A square. A square was same as matrix A. That means we have idempotent matrix. In case of idempotent matrix, any power of that matrix is matrix A only. So if a square is a raised to n will be a, and therefore these two terms they will cancel. So basically we had to satisfy the condition that omega raised to n into b raised to n, this must be matrix B, right? So from here we have two conditions. One condition omega raised to n is 1, and second condition b raised to n is b. Now omega raised to n is 1, that means omega n must be multiple of 3. So from there we got these values of n. Remember, we need to satisfy both of these conditions, and therefore finally we had to take intersection. So this was if I take n as multiple of 3, then we can satisfy the first condition that omega raised to n will be 1. And B cube, this was matrix B, which means we have a periodic matrix with period 2. And then if B cube is B raised to 5, 7, 9 and so on, all of them, that will be matrix B only. So if I have to satisfy the second condition that B raised to n, this is matrix B, then n must be odd natural numbers, 1, 3, 5, 7 and so on. And because we have to satisfy both the conditions, we need to take intersection of those two. So this was the intersection of first and second set of values of n. And now in this set, total number of elements is 17. And therefore, the correct answer for this problem is 17. Let A be this 3 cross 3 matrix, and for some theta belonging to 0 to pi, A square is same as A transpose. Then we have to find the sum of diagonal elements of this matrix A plus I raised to 3 plus A minus I raised to 3 minus 6A. Now, this is a very interesting problem from one important type of matrix, that is orthogonal matrix. Now, in case of orthogonal matrix, generally we learn the basic definition of orthogonal matrix, that a matrix is called orthogonal matrix if A into A transpose, that is identity matrix, right? If you multiply a matrix and its transpose, and if the result is identity matrix, then we say that this matrix is orthogonal matrix. However, this definition is not that much useful when we have to identify whether a matrix is orthogonal or not by observation, right? In case of orthogonal matrix, I mean, this is the definition that A into A transpose, if that is I, then matrix is orthogonal. But the problem with this definition is that only after calculating A into A transpose, uh, you can identify whether the matrix is orthogonal or not. That means first we need to find A into A transpose, and if that is identity matrix, then only we can claim that it will be orthogonal matrix. However, if you are familiar with properties of orthogonal matrix, then simply by observation you can tell whether a matrix is orthogonal or not. So there are two important properties. The very first one is that in case of orthogonal matrix, every row is perpendicular to every other row, right? If you take any row vector and if you take the dot product of that row vector with any other row vector, then you should get a 0, right? For example, here let us say this is R1 and then this one is R2 and finally this one is R3. Now here if you take R1 dot R2, let us say R1 is this vector where we have cos theta, 0 and minus sin theta as x, y and z component. So if I take R1 dot R2, then we should get a 0. Clearly you can see cos theta into 0, 0 into 1 and then minus sin theta into 0. Or if you take R1 dot R3, then also the result will be 0. Right? You can take any one row and any other row, and those two row vectors, they are perpendicular vectors. That means their dot product will be 0. You can take R1, R2, R1, R3 or R2, R3. And same thing you can say for columns also. That means first column C1, this is perpendicular to C2, right? First column C1, this is perpendicular to C3. And similarly, second column C2, this is also orthogonal to C3. Hence the name orthogonal matrix. In case of orthogonal matrix, every row vector and every column vector, they are perpendicular to every other row or column vector, right? R1, R2 are perpendicular, R1, R3 are perpendicular, and so on, right? So, and also all the row vectors and column vectors, they are unit vectors. That means if I take vector R1 dot R1, then the result will be 1. Same thing you can do for R2 dot R2 or C1 dot C1. For example, here R1 is cos theta 0 and minus sin theta. If I take the dot product with itself, then we'll get cos square plus sin square, which is 1. So if you are familiar with this property of orthogonal matrix, then by observation you can tell that matrix A is orthogonal matrix, and that will imply that if we have orthogonal matrix, then it means A into A transpose, this must be identity matrix, right? So here it is given that A square, this is same as A transpose. Now if A square is A transpose, you can multiply both side by matrix A, and then on left hand side we have A cube, and right hand side will be A into A transpose, which is identity matrix, because the given matrix is orthogonal matrix. And now the problem becomes much easier. We need sum of diagonal elements or the trace of this matrix. Now let us say this matrix is B. So first we are going to simplify this matrix B, and then we'll calculate trace of matrix B. And for simplifying, we can use A plus B whole cube formula. So this matrix B, this will be, and because these are commutative matrices, we can use those binomial theorem, binomial expansion of A plus I raised to 3. So this will become A cube plus 3A square plus 3 into A plus I. Remember, generally matrix multiplication is not commutative. That means AB and BA, these two are not same. And therefore, we cannot use the standard formula of A plus B square or A plus B cube and so on. But if one of the matrix is identity matrix, then it becomes commutative. A into I, this is same as I into A. And therefore, we can use those formula of A plus B cube or A plus B square and so on. So this will be matrix A plus I cube. Similarly, A minus I cube, that will be A cube minus 3A square plus 3A minus I minus 6A. And now you can see that 3A plus another 3A minus 6A. So these three will cancel. 3A square minus 3A square will cancel. I and minus I, these two will cancel. So basically matrix B, this is twice of A cube, and A cube was same as I. That means after simplification, this matrix B is nothing but 2 into I. We need a trace of this matrix B. So trace of matrix B, this will be twice of trace of identity matrix. And for 3 cross 3 identity matrix, sum of diagonal elements, there will be 3. So therefore trace of I, which is trace of I, that will be 3, and hence trace of matrix B, this will be 2 into 3, which is 6. So the correct answer for this problem will be 6. Now this was important concept because if you are familiar with this definition of orthogonal matrix, then simply by observation, you can identify whether a matrix is orthogonal or not. Otherwise, you will have to calculate A into A transpose, right? So always remember that in case of orthogonal matrix, every row is perpendicular to every other row. Same thing for column. And each row vector and column vectors, they are unit vectors. That means if you take dot product of row vector with itself, we must get 1. And also for orthogonal, you can remember one more result, that because A into A transpose, this is identity. In case of orthogonal matrix, A inverse, this is same as A transpose. Because if two product of two matrices is I, identity matrix, then each one is inverse of other. So for orthogonal matrix, inverse is nothing but transpose of the matrix, right? So for this problem, I mean after simplification, matrix B was 2I, and therefore trace of matrix B, this will be 6. And that is the correct answer for this problem. Let A be a 3 cross 3 matrix such that determinant of adjoint of adjoint of adjoint of A, this is 81. If S is set of all integers n which satisfies this equation, n belongs to Z, that means n is integer, and it satisfies this equation that determinant of adjoint of A, that raised to n minus 1 square by 2, this is determinant of A raised to 3n square minus 5n minus 4. Then we have to find the value of sigma n belonging to S, determinant of A raised to n square plus n. So basically in this problem, first we have to find all the integral values of n which satisfies this equation, right? And for that we need to use properties of adjoint of a matrix. So we know that if we have determinant of adjoint of any matrix, and this adjoint is given a number of times. Then for this we have a standard formula that this is determinant of A raised to n minus 1 and this raised to k, where n is the order of matrix. For example, here the given matrix is 3 cross 3 matrix, so n will be 3. And this k is the number of times that we have adjoint. For example, here we have adjoint 3 times, so therefore this k will become 3. And this is given as 3 raised to 81, so this we can write as 3 raised to 4. Now determinant of A, and this raised to n minus 1, so n is 3, that means n minus 1 will be 2, and adjoint we have 3 times, so 2 raised to 3, right? K will be 3 and n is also 3, so 2 cube, that will be 8, and this is 3 raised to 4, right? So determinant of A raised to 8, this is 3 raised to 4. So from here you can write determinant of A as plus minus root 3 or determinant of A square as 3. So that will be the determinant of given matrix A. Determinant of A is plus minus root 3 and determinant of A square, this is 3. Now let us try to find the value of n using this equation, right? Let us try to find the set S, because n is all the elements of this set S, right? N belongs to S. So now let us try to find S. For that, again, we are going to use the same formula, that determinant of adjoint of A. So this will be determinant of A raised to n minus 1. Now because n is 3, n minus 1 will be 2. And here we have adjoint 2 times. So that means if I use this formula, that n is 3 and k is 2, right? So n minus 1 will be 2 and 2 raised to 2, so that will be 4, right? So determinant of adjoint of A for this 3 cross 3 matrix, that will be determinant of A raised to 4 and this raised to 1 by 2 into n minus 1 square. And on right hand side we have determinant of A and this raised to 3n square minus 5n minus 4. And now as you can see that for these two sides the base is same, it is determinant of A, so therefore we can equate the exponent. So 4 raised to 1 by 2 into n minus 1 square, so this will be nothing but 2 into n minus 1 square, and n minus 1 square means n square minus 2n plus 1. And on right hand side we have 3n square minus 5n minus 4. So 3n square minus 2n square, that will give us n square, minus 5 plus 4, so that is minus n, and minus 4 minus 2, that is minus 6, this equals to 0. From here clearly you can see that factors will be n minus 3 and n plus 2. And if this is 0, so from here we are going to get two different values of n. We'll get n as minus 2 and plus 3, and both of these are integer only, right? So that means here our set S, now we are in a position to write the set S. S will be set of these two elements. In set S we have minus 2 and plus 3, right? This is our set S. Now finally we need to calculate this one. We have to find determinant of A raised to n square plus n, and n belongs to S. There are two elements in S, so therefore in this summation there will be two terms. The very first term will be, now we can write the answer. The very first term will be determinant of A raised to n square plus n, and in place of n we can take 3. So if I take n as 3, 3 square will be 9 and 9 plus 3, that will be 12. Plus second term will be determinant of A. Remember here we have this property that if I have determinant of A raised to n, so we can take that exponent outside and we can write in this form, that is determinant of A raised to n. Exponent we can take outside the sign of determinant. So determinant of A raised to 12, this when we'll take n as 3, and if I take n as minus 2, then we'll get minus 2 square 4, 4 minus 2, that will be 2. So this will become determinant of A square is 3. So determinant of A raised to 12 means square raised to 6. So we have 3 raised to 6, and then determinant of A square, this is 3. 3 raised to 6 will be 27 square, which is 729 plus 3. So that is 732. So therefore the correct answer for this problem will be option B. Right? This was a very interesting problem from the simple concept that if I have determinant of adjoint of a matrix and adjoint is given k times, then for that we have this standard formula determinant of A raised to n minus 1 raised to k, where n is the number of times we have adjoint and n is the order of matrix. So using that standard formula, first we calculated determinant of A square. Then by equating the exponent, we got two values of n, and that means this was set of minus 2 and 3, and finally we had to calculate this one. So the right answer for this problem is option D. Let capital A represents a 3 cross 3 matrix such that it satisfies these three equations. A into this column vector 0 1 0, this is 0 0 1. Similarly, A into another column vector, this is 0 1 0. And finally, A into this column matrix 2 1 2, this is 1 0 0. Then we have to find the element of second row, third column for this matrix A. Now, the general method of solving this problem is to start with a general 3 cross 3 matrix, and then using these equations, we have to find the elements of matrix A. But there is another much easier method of solving such problem, and these type of problems, they are very common in JEE Main, where you have one unknown 3 cross 3 matrix A, and then there are three matrix equation and something related with matrix A. This is asked in the problem. So here what we can do is that we can combine these three matrix equation and we can create a single matrix equation. Also here, if you notice, these right hand side, they are nothing but columns of identity matrix. So here in fact you can create a matrix equation of the form A into some other matrix B equals to identity matrix. And if we have that equation, that A into B, this is I, then clearly matrix A, this is nothing but inverse of matrix B, right? Matrix A will be B inverse and matrix B, this will be A inverse. So, but for that we have to know how we can combine these three equations and we can write a single matrix equation. So see, in case of identity matrix, the first column is 1 0 0. Now here 1 0 0, this is given in the third equation, right? 1 0 0, that is third equation. So we are going to write this equation first. That means right hand side 1 0 0, and on left hand side we have A into 2 1 2. So for this matrix B, the first column will be 2 1 2, and matrix A multiplied by this column matrix 2 1 2, that will give us 1 0 0. Similarly, for identity matrix, the second column is 0 1 0. This column is given here, right? So therefore the left hand side for this matrix B, the second column, that should be 4 1 3, and matrix A multiplied by this column matrix 4 1 3, that will give us this column 0 1 0. And finally, for identity matrix, the last column, this is 0 0 1, the third column. So and for matrix A into this column 0 1 0, that is 0 0 1. So matrix A multiplied by this third column, that will give us 0 0 1. So now we have this equation that A, and if I call this second matrix as matrix B, so then we have this equation of the form A into matrix B equals to identity matrix. And if A into B is identity matrix, then matrix B, this is nothing but A inverse. And now we can calculate anything related with matrix A, because in fact, matrix B is A inverse, and you can also show that you can also write the same thing as matrix A is inverse of matrix B, because here matrix B is known and it is matrix A that we have to find, right? In fact, we have to find the element in second row, third column, right? We have to find A 2 3 for this matrix A. So now let us try finding B inverse, right? Now we are going to find inverse of matrix B, and then we'll see what should be the element in second row, third column for this matrix B. Now remember, for finding inverse of any matrix, we need two things. One is the adjoint of matrix, other one is determinant of the matrix. So first let us calculate determinant of matrix B. Right, determinant of matrix B, we can expand along the third column because we have two zeros there. So we can write minus 1 into, and then we have 2 into 3 6, minus 4 into 2, that will be 8. So determinant of matrix B, this is 2, right? So that means B inverse, this will be nothing but determinant of matrix B, and that multiplied by adjoint of matrix B. Now remember, adjoint is nothing but transpose of cofactor matrix. Here we are not going to calculate all the elements because we are interested only in the element of second or third column. So for B inverse will be adjoint of B and that divided by determinant of B, and adjoint is transpose of cofactor matrix. And for matrix A, we need the element of second row, third column, right? So that you will get from the element of third row, second column after taking transpose of the matrix. So here we'll not write the element of first row, we'll not write the element of second row also. And in third row, only will find this element, right? Element of third row, second column. Because once we take transpose, then we are going to get the element of second row, third column. So now this element, this will be cofactor of element in third row, second column. That means cofactor of this element 3, right? So that will be 2 into 1 minus 1 into 0, that is 2. Minor will be 2. And for this particular element, I plus j will be odd number. So if minor is 2, cofactor will be minus 2. That means for B inverse, the element of third row, second column, this is minus 2. And after taking transpose, this element will come to second row, third column, right? So therefore, from here directly you can write A2, 3. Once we take transpose of this cofactor matrix, then this minus 2, this will come to second row, third column, and that divided by determinant of matrix B. So that will be minus 2 divided by 2, which is minus 1. So this should be the element of second row, third column, and hence the correct answer for this problem, this will be option B, right? So this is very interesting concept, and there are number of PYQs from this concept where you have one matrix A, a known matrix, and three matrix equation, and then you have to find something related with this matrix A, right? So in that case, you can always combine all of those three equations and you can write matrix equation of this form. Here we got identity matrix, but in some other problem, you might get some matrix C. But in that case also, I mean, if I can write this equation that matrix A into B, this is some matrix C, and B and C, these two are known matrix, we have to find matrix A. So then multiply both sides by inverse of matrix B. So matrix A, this will be nothing but C into B inverse, right? And sometimes there are determinant related problem that find determinant of matrix A. So then you can take determinant on both sides and from there you can calculate these things. So it is an important concept and you should know how to combine these matrices, matrix equation. Here after combining, we got matrix A as B inverse. Then we calculated B inverse, and because we were interested only in the element of second row, third column, so we calculated only this particular element, right? And finally, A to 3, this was minus 2 by 2, which is minus 1. And hence the correct answer for this problem is option B. Let A be a 3 cross 3 matrix. Determinant of A is 2 and N is determinant of adjoint of A, and here we have this adjoint 24 times. If this number N is divided by 9, then we have to find the remainder, right? So this is another interesting problem from matrices and determinant, and it also involves concepts from binomial theorem, right? How to find remainder when a number is divided by another number. So first of all, this given number n, I'll represent this number by capital N. So let us say this number n, this will be determinant of A raised to n minus 1 and that raised to k. This is the standard formula for finding determinant of adjoint of a matrix, where adjoint is given a number of times. In this formula, n is the order of matrix. For example, here we have 3 cross 3 matrix. So that means n will be 3. And k is the number of times we have adjoint. For example, here we have adjoint 24 times. So that means k will be nothing but 24. So determinant of A is 2, n is 3, so n minus 1 will be 2, and then this raised to 2024. This is number n, and this number is divided by 9. So then we have to figure out the remainder. Now remember, when we are dividing by 9, we have to see that which exponent of 2 that will be multiple of 9 plus minus 1, right? So clearly you can see that 2 cube, this will be 8, and 8 is nothing but 9 minus 1, right? So here basically first we'll try to identify this number 2 raised to 2024, right? We'll try to figure out that 2 raised to 2024, is it multiple of 3, multiple of 3 plus 1, or multiple of 3 plus 2, right? Because that will give us, that will, in that manner, we can write this as 2 raised to multiple of 3 plus something, and then we can use the binomial expansion because 2 cube is 9 minus 1 and we are dividing by 9. So here, 2 raised to 2024, this you can write as minus 1 plus 3, and this raised to 2024. And now if I expand it using binomial theorem, then clearly you can see that minus 1 raised to even power, that will be 1, and after that all the other terms will be multiple of 3. So that means 2 raised to 2024, this is nothing but multiple of 3 plus 1. So therefore we can write this number n as 2 raised to multiple of 3 plus 1, right? 2 raised to 2024, 2024 is multiple of 3 plus 1. So this number n will be 2 raised to 3m plus 1, where m is some positive integer. Now here you can separate this 2, and then this we can write as 2 cube raised to m, and 2 cube is 8, 8 is minus 1 plus 9. So we have minus 1 plus 9 raised to m, right? We are trying to write this number capital N as multiple of 9 plus something so that we can get the remainder. Now this becomes 2 into, and then if I use binomial theorem here, then we'll get minus 1 raised to m plus, and after that all the other terms will contain at least one 9, right? Next term will be mc1 into 9 raised to 1, next term mc2 9 square, and so on. Alternately we have to change the sign because of this minus 1, but the point is that only this first term will not contain 9. After that all the other terms, there will be multiple of 9 only. So therefore we can write this number as minus 1 raised to m plus 9 into some integer k, right? K is some integer. So now we have to find whether m is odd number or even number, because if m is odd number, then minus 1 raised to m will be odd, and if m is even number, then minus 1 raised to m, that will be even number. So for that we have to see this equation, right? We got 2 raised to 2024, this was multiple of 3 plus 1. Left hand side is even number, 2 raised to 2024, that should be even number. So that means right hand side must be even. If 3m plus 1 is even, then 3m must be odd, and if 3m is odd, m must be odd number, right? Because if m is even number, then 3 into m is even, even plus 1 will be odd, and the left hand side is even. So then we cannot make the two sides equal. So from here you can very easily see that m must be odd number. Then only we can make the two sides equal, right? So if m is odd number, then this number n, this will become 2 into and multiple of 9 minus 1, right? Minus 1 raised to odd number, that will be minus 1. So therefore this number n, this will be 2 into multiple of 9 is still multiple of 9 minus 2. Right, so the required number n, this will be of the form multiple of 9 minus 2. And if I divide this number by 9, then the remainder will be minus 2 plus 9. Right, remainder is never negative. If we get negative remainder, that means we have over divided. So that means we need to add 9 here. So if the number is of the form multiple of 9 minus 2, that means it is of the form multiple of 9 plus 7. Right, so if we divide by 9, the remainder must be 7. So therefore, the correct answer for this problem, that will be 7, right? So this was one very interesting problem from matrices and determinant, and also it has concepts from binomial theorem. From matrices and determinant, this number n will be 2 raised to 2 raised to 2024, because adjoint was 2024 times and n is 3. And then first we have written 2 raised to 2024 as multiple of 3 plus 1. And then after that, finally we got this number n as multiple of 9 minus 2. If we divide this number by 9, the remainder will be 7. And therefore, the correct answer for this problem is 7. A is this 2 cross 2 matrix. if sum of the diagonal elements of A raised to 13, this is 3 raised to n, then we have to find the value of n. Now, in most of the resources, you will find that for calculating the trace of this matrix A raised to 13, sum of diagonal elements is nothing but the trace of the matrix. So for finding trace of A raised to 13, they will multiply this matrix A. First, they will calculate A squared, then A raised to 4, A raised to 8, and so on. And then they will calculate the sum of diagonal elements. But there is another much easier method of solving these type of problem. And in last few years in JEE Main, you will find that there are a number of PYQ where some matrix is given, and you have to find sum of diagonal elements of that matrix raised to some large power like 13, 15, and so on. So these type of problems one can easily solve if you are familiar with the concept of eigenvalues of a matrix and properties of eigenvalues. Right, first we'll talk about what is eigenvalues of a matrix. We already know about characteristic equation, right? We learned about characteristic equation of a matrix in Cayley-Hamilton theorem. So from there we can find eigenvalues of a matrix. And then there are few properties of eigenvalue that you should know. So then these type of problems you can solve within few seconds. So basically eigenvalues are nothing but they are but roots of characteristic equation of a matrix. And what is characteristic equation? Determinant of A minus lambda equals to 0. So that means from diagonal elements, we subtract lambda and then equate the determinant to 0. So from there, we get a polynomial equation in lambda. For 2 cross 2, we'll get quadratic equation. For 3 cross 3, we'll get cubic equation and so on. So that equation is called characteristic equation of the matrix. And the root of this characteristic equation, they are called eigenvalues, right? Also for 2 cross 2 matrix, there is one direct formula also to write characteristic equation, lambda square minus trace of A into lambda plus determinant of A, this equals to 0. Using this formula in one line, you can write the characteristic equation of any 2 cross 2 matrix. And the root of this characteristic equation, they are called the eigenvalues of the matrix, right? So let us say for this quadratic equation, the roots are lambda 1 and lambda 2. So these lambda 1 and lambda 2, they are eigenvalues of this matrix A. Now, there are few properties of eigenvalue that you should know. The very first property is that if you multiply the eigenvalues of a matrix, then you will get determinant of the matrix, right? Product of eigenvalue, this is always determinant of A, which is obvious from here also. For this quadratic, product of root lambda 1 and lambda 2, that will be determinant of A. Similarly, if you find the sum of eigenvalues, right, if you calculate the sum of eigenvalues of a matrix, I'm writing for 2 cross 2, but this is valid for any general n cross n matrix. So product of eigenvalue, this is determinant of the matrix, and sum of eigenvalue, this is nothing but trace of matrix, right? So these are the two most frequently used properties. And for solving such type of problem where you need trace of A raised to n, there is one more property that you should know, and that is for a matrix A, if the eigenvalues are lambda 1 and lambda 2, again I'm writing for 2 cross 2, but valid for any general n cross n matrix, then for A raised to n, the eigenvalues are lambda 1 raised to n and lambda 2 raised to n. Now, this is very important result because for suppose if I know eigenvalue of matrix A, they are lambda 1, lambda 2. So for A square, it will be lambda 1 square, lambda 2 square. For A cube, lambda 1 cube, lambda 2 cube, and so on. So here what we'll do is we'll find the eigenvalues of matrix A, and then for A, let us say for matrix A, the eigenvalues were lambda 1, lambda 2. So what should be eigenvalues of A raised to 13? This will be lambda 1 raised to 13 and lambda 2 raised to 13. That will be eigenvalue of this matrix A raised to 13. And then the trace of this matrix A raised to 13, that will be nothing but sum of the eigenvalues, right? So that means lambda 1 raised to 13 plus lambda 2 raised to 13. So that will be the sequence of steps. First find the eigenvalues of matrix A. From there find the eigenvalues of A raised to 13. And then the trace of matrix A raised to 13, that is nothing but sum of eigenvalues. So here if I have to find eigenvalues of matrix A, then it will be lambda square minus trace of matrix A. So for matrix A, trace means sum of the diagonal elements. So that will be 2 plus 1, 3. right? So lambda square minus 3 lambda plus determinant is also 3. So this is the characteristic equation for matrix A, right? For matrix A, the characteristic equation using that standard formula is lambda square minus 3 lambda plus 3 equals to 0. And now let us try to find the roots of this equation. So clearly you can see that for this equation, the discriminant is negative. So therefore we'll get imaginary roots. The roots will be minus b plus minus root over b square minus 4ac and that divided by 2a, right? So that means one of the eigenvalue, this is 1 by 2 we can take outside. So one of the eigenvalues is 3 plus root 3 iota and the other eigenvalue lambda 2, this is 3 minus root 3 iota. These are the two eigenvalues of matrix A. So now trace of this matrix A raised to 13, this will be nothing but sum of eigenvalues of A raised to 13. And for A raised to 13, eigenvalues are lambda 1 raised to 13 and lambda 2 raised to 13. So now basically we have to calculate this sum and then we'll get trace of matrix A raised to 13. Also this is given as 3 raised to n. So by comparing, we'll find the value of n. Now, in most of the problems, you will get simple eigenvalues, right? Simple integers, but here we are getting a complex number. So if I have to calculate any large power of a complex number, then we know that we have to express that complex number in polar form or Euler's form, and then use the De Moivre's theorem, right? So if I say that this complex number, let us say lambda 1, this I'm representing as Z1. So this is 3 by 2 plus root 3 iota by 2. So now how to write this complex number in polar form or Euler form? So for that we need the modulus and the argument of this complex number. Now modulus of this complex number will be 9 by 4 plus 3 by 4, that is 12 by 4. So root over 3, right? So modulus is root over 3 and the argument is uh, 1 by root 3, so that will be 30 degrees. So that means argument is pi by 6. So the first complex number in Euler form, this will be root 3 e iota pi by 6, this raised to 13. And the second one is conjugate of this one. So that means root 3 e minus iota pi by 6 and this raised to 13. Now root 3 raised to 13, with this we can take common. And then you have e iota 13 pi by 6 and plus the other one will be e iota in fact e raised to minus iota and then we have 13 pi by 6. Now 13 pi by 6, this we can write as 2 pi plus pi by 6. 2 pi we can remove, pi by 6. So cos pi by 6 plus iota sin pi by 6, and from here the imaginary part will cancel. So basically you will get 2 into, in fact this number outside, this was root 3 raised to 13, and here you will get 2 into cos pi by 6 because the iota sine pi by 6, that term will cancel with this conjugate, right? And the real part you will get twice. So cos pi by 6 root 3 by 2, that means ultimately this is root 13 raised to 13 into root 3, that means 3 raised to 7. So from here clearly you can see that value of n, this will be nothing but 7, right? So using this concept of eigenvalues, one can very easily solve this problem. And there are multiple PYQ in JEE Main as well as in JEE Advanced, where using this concept of eigenvalue within few lines, you can solve these type of problems. So for that, just remember these three properties. First of all, eigenvalues, they are roots of characteristic equation. For 2 cross 2 matrix, this is the standard formula to write characteristic equation. Sum of eigenvalues trace, product of eigenvalues determinant, and for a raised to n, the eigenvalues are lambda 1 raised to n, lambda 2 raised to n. So first we calculated eigenvalues of matrix A, then from there we got eigenvalues of a raised to 13, and then trace of this a raised to 13, this is nothing but sum of the eigenvalues. Ultimately this trace was 3 raised to 7, so therefore the value of n, this will be 7, and that is the correct answer for this problem. In JEE Main, the problem on system of linear equation is not uncommon. There are multiple PYQs based on system of linear equation having unique solution, no solution, or infinite number of solution. This is one of those problems. S is set of all the real values of lambda for which this system of linear equations. You can see that first equation lambda x plus y plus z equals to 1. Second equation, x plus lambda y plus z equals to 1. And the third equation, x plus y plus lambda z equals to 1, is inconsistent, right? This system of linear equation is inconsistent. Lambda is set of all those values for which this will be inconsistent. S is set of all those values for which this will be inconsistent. Then we have to find this one, summation lambda belonging to S, modulus of lambda square plus mod lambda. Now, the meaning of this word inconsistent is that this system of linear equation will have no solution, right? Inconsistent simply means that it will have no solution, right? Either it will have, I mean, consistent means that it will have solution, either unique solution or infinite number of solution. And inconsistent means that there is no solution for this system of linear equation. So the condition for no solution is that determinant of coefficient matrix, this one is 0, and then any one of these three, right, delta 1, delta 2 or delta 3, at least any one of these three, this is non-zero, right? That means delta is 0, delta 1 is non-zero, or delta 2 is non-zero, or delta 3 is non-zero, then it will have no solution, right? So the necessary condition for inconsistency is that delta must be 0. So first, let us try to find the values of lambda from there, right? And then we'll see whether, I mean, for those values of lambda, what should be the values of delta 1, delta 2, and delta 3. So here, for inconsistent or for no solution, the condition is delta is 0. If I equate delta to 0, that is, if I equate the determinant of coefficient matrix to 0, then for determinant of coefficient matrix, the first row will be lambda 1, 1. The second row is 1, lambda 1. These are nothing but coefficient of x, y, z. Third row, this will be 1, 1, lambda. Right, first row is coefficient of x, y, z in first equation. Similarly, second row, coefficient of x, y, z in second equation, and so on. Now, if the system of linear equation is inconsistent, this must be 0. Remember, this is necessary but not sufficient condition, because delta should be 0 and then any one of remaining three, delta 1, delta 2 or delta 3, that should be non-zero. So here if I expand this determinant along the first row, let us say, so then we'll get lambda into lambda square minus 1, and then minus 1 into lambda minus 1, right? Minus 1 into lambda minus 1, and then plus 1 into 1 minus lambda, and this must be 0. Lambda minus 1 you can take common from all of these. So from first term you will get lambda into lambda plus 1, and from here you will get minus 1, another minus 1, so that is minus 2. So we have lambda minus 1, and then we have lambda square plus lambda minus 2, this equals to 0. So from here we are getting these three values of lambda, 1, 1 and minus 2, right? I mean, you will get 1 from here, and the roots of this quadratic, that will be 1 and minus 2. So these are the three values of lambda that we are getting, right? Now, if you take lambda as 1, right? If I take lambda as 1, then our system of linear equation, this will become x plus y plus z equals to 1. Second equation also x plus y plus z equals to 1. And the third equation is same, x plus y plus z equals to 1. Now here we don't have to calculate delta 1 and delta 2 and delta 3. Directly you can see that this system of linear equation will have infinitely many solutions, right? Because all the three equations, they are identical, right? Take any value of x, y, z which satisfies equation 1, then it will also satisfy equation 2 and 3, right? So for lambda equals to 1, we are not going to get no solution, right? For lambda equals to 1, the system of linear equation will be consistent and it will have infinitely many solutions, because any xyz satisfying equation 1 will also satisfy 2 and 3, because all the three equations are identical, right? So lambda equals to 1, this will give us infinitely many solution. So the only other value that we are getting is minus 2, right? And none of the options are 0, so therefore only value of lambda for which it will be inconsistent is minus 2, right? If you want to be more sure, then you can write the system of linear equation for lambda equals to minus 2. If lambda is minus 2, then the first equation was lambda into x, right? First equation lambda into x, so minus 2x plus y plus z, this equals to 1. Second equation x minus 2y plus z equals to 1. And in third equation, we had 1, 1 lambda. So that means x plus y minus 2z equals to 1. Now here you can calculate delta 1 and you will find that delta 1 will be non-zero. But there is no need to calculate this one also, because for 1 we have found that uh, for 1 the system of linear equation is consistent. It will have infinitely many solutions. So only other value of lambda that is left is minus 2. And if this will also not satisfy that condition, then sum of this value will be 0. There is no option 0 here. So that means minus 2 must, for minus 2, the system of linear equation must be inconsistent. And if you want to be 100% sure, then you can obviously write the system of linear equation and calculate delta 1, right? So the only value of lambda for which it will be inconsistent is minus 2. Now we need this summation lambda square plus lambda, and lambda belongs to S. There is only one element in set S. That element is minus 2. So minus 2 square, that will be 4, plus modulus of minus 2, that is 2. So 4 plus 2, that is 6. So that should be the correct answer for this problem. Right, so in this problem, for no solution, or if the system of linear equation is inconsistent, then delta will be 0, and any one of these three, at least any one of these three, that will be non-zero. By equating the delta to 0, we got three values of lambda, 1, 1 and minus 2. When lambda is 1, we are getting infinitely many solutions, and when lambda is minus 2, then we are getting no solution. So therefore, the only value of lambda in this set S, that will be minus 2, and for that this sum will be 6. So the correct answer for this problem is option D. Consider the system of linear equations. There are three equations and three unknowns x, y, z, right? Three variables. If this system of linear equation has infinitely many solutions, then we have to comment about another system of linear equation in K, right? Variables are x and y, and we have this system of linear equation, two equations, two unknowns, right? And we have to comment about this system of linear equation, that whether it will have unique solution or no solution or infinite number of solution, right? And also for unique solution, there are two different cases. Now we know that for infinitely many solutions, right? If we have a system of linear equation, three equations, three unknowns, then for infinitely many solutions, the condition is that determinant of coefficient matrix, this is 0, and then delta 1, delta 2, and delta 3, these three are also 0, right? This is the condition for infinitely many solution. Now, because there is only one unknown in this equation, k, so using this condition, delta equals to 0, we can get the value of that k, right? And once we have the value of k, then we can comment about this system of linear equation, that whether it will have which one of these options, unique solution, no solution, or infinitely many solutions. So first of all, let us equate the determinant of coefficient matrix to 0, and then see what is the value of k that we are getting, right? So because it has infinitely many solutions, the determinant of coefficient matrix must be 0. That is necessary condition, but not sufficient condition. Sufficient condition will be that delta is 0 and these three are also 0. But because we have to find the value of this unknown k only, there is only one unknown. So by equating delta to 0, we can get the value of that k. So for delta, the first row will be 1, 1, and then k. Second row will be 2, 3, and minus 1. These are nothing but coefficient of x, y, and z. First row means coefficient of x, y, z in first equation. Similarly, second and third equation. So third row, this will be 3, 4, and 2. So this is the determinant of coefficient matrix. And because the system of linear equation has infinitely many solutions, this must be 0, right? So if I expand along, first row will get 1 into, and then 3 into 2, 6 plus 4. So that will be 10, minus 1 into, and then 4 plus 3, that will be 7, and then plus k into 8 minus 9, that is minus 1, and this must be 0. So from here we'll get k equals to 10 minus 7, that is 3. So this is the value of k that we are getting, right? If the system of linear equation has infinitely many solutions, then k must be 3. And now let us substitute that value here in this equation and try to see what type of equation we are getting. So if k is 3, the first equation will be 4x plus 5y, and this equals to 7. Second equation will be, in place of k, if I write 3, then we have 7x plus, here we'll get 3 plus 5, so that is 8y, and on right hand side we'll get 10. Right, so this is the system of linear equation. Now for two equations, two unknown, we know the condition. I mean, if we have this system of linear equation, a1x plus b1y plus c1 equals to 0, and another system of linear equation, a2x plus b2y plus c2 0. So these are nothing but equation of a straight line in 2D, right? Linear equation in x and y, that will represent a straight line in 2D. And if a1 by a2, this is not equal to b1 by b2, then it means the lines are not parallel, and in that case we'll get unique solution. Also, for infinitely many solution, a1 by a2 is equal to b1 by b2, it's same as c1 by c2. And for no solution, these two are equal, a1 by a2 same as b1 by b2, but not equal to c1 by c2. That means in that case the lines are parallel. So here if you notice, we are getting this first case, right? A1 by a2 4 by 7, this is not same as 5 by 8, or clearly for these two lines their slopes are different. So that means we'll get a point of intersection between these two lines, and therefore we'll have unique solution. So no solution and infinitely many solution, these two options are incorrect. Now we have to check whether we are getting solution satisfying this condition, x minus y equals to 1 or x plus y equals to 1. So for that, either you can solve these two and then find sum or difference of those two roots. But here directly also you can see that if I do 2 minus 1, right? If I let us call this equation as 1 and this equation as 2. So if you do equation 2 minus 1, then you will get 7 minus 4, which is 3x, and 8 minus 5, which is 3y, and right hand side 10 minus 7, that is 3. Divide by 3, and then we have this option x plus y equals to 1. So therefore, this system of linear equation will have unique solution satisfying this condition, x plus y equals to 1. That means sum of those two, when the sum of solution, that x plus y, that will be 1, right? So this was a problem where first we had to find the value of k using the condition that this system of linear equation has infinitely many solutions. So for that, condition is delta 0, and then delta 1, delta 2, and delta 3, those three are also 0, because there was only one unknown k. So by equating delta to 0, we got k as 3. Once we have k as 3, we got these two equations. And because a1 by a2 is not same as b1 by b2, the lines are not parallel, we'll get unique solution. And if we do 2 minus 1, then the solution will satisfy this condition, x plus y will be 1. So therefore, the correct answer for this problem is option C. Consider this system of linear equations. There are three equations in three variables, and in equation 3 there are two unknowns, lambda and nu. It is given that this system of linear equation has infinitely many solutions. Then we have to find the radius of circle centered at this point lambda nu, and touching this line 4x equals to 3y. So basically from here we have to find the value of lambda and nu using the condition that this system of linear equation has infinite number of solutions. And once we have lambda and nu, the center of circle will be known, and then because it is touching this line, the line is tangent to the circle, radius of the circle, that will be nothing but perpendicular distance from the center of circle on this line. So basically the problem is to find the value of lambda and nu, and then we can find the radius of circle by calculating the perpendicular distance of this line from the point lambda nu. Also, in some of the problems, you'll find that instead of writing infinitely many solutions, they will write that this system of linear equation has more than one solution, right? So in that case also, it will mean the same thing. A system of linear equation can have only three possibility. Either it will have unique solution or no solution or infinite number of solution. So if it has more than one solution, then also it will have infinite number of solution. Now, we know that for infinitely many solutions, the condition is that delta is 0, that is determinant of coefficient matrix is 0, and delta 1, delta 2, and delta 3, these three, they are also 0, right? So by using these conditions, we have to find values of lambda and nu, and then we'll calculate the radius of this circle by calculating the distance of that tangent line from the center of circle. So now let us try to find lambda first. For infinitely many solution, the determinant of coefficient matrix, this must be 0. That means in first column, we'll have uh, 2, 7, and then 12. Right, that should be the first column of coefficient matrix. Coefficient matrix means these numbers 2, 3, 5, 7, 3, minus 2, and then we have 12, 3, and minus 4 plus lambda. So first column 2, 7, 12. Then second column is 3, 3, 3. And finally the third column, this will be 5, then minus 2, and then minus lambda minus 4. Right, so this is the determinant of coefficient matrix. And because the system of linear equation has infinitely many solutions, this determinant must be 0. Now, it is not difficult to solve this determinant. If you want, you can create two zeros also, because we have identical element in second column. So if you want to create two zeros, you can do this row operation, that in place of R1, you can write R1 minus R2, and in place of R2, you can write R2 minus R3. Using this row operation, we can get two zeros uh, in one row or one column, and then we can expand along that row which have maximum number of zeros. So if I do 2 minus 7, that will be minus 5, 3 minus 3, that will be 0, 5 minus 2, this will be 7. Similarly, 7 minus 12, so again minus 5, 3 minus 3 is 0, and then lambda plus 2. And here we have 12, then we have 3 minus lambda minus 4, and this determinant must be 0. So if I expand this determinant along the second column, because we have two zeros here, then we'll get minus 3 into, and then we have minus 5 into lambda plus 2, and then plus 7 into 5, so that is 35. This equals to 0. So from here, clearly you can see that the value of lambda plus 2, this will become 7. That means lambda must be 5. So this must be the value of lambda, right? By equating the determinant of coefficient matrix to 0, we got lambda as 5, right? We need lambda and nu. So we have calculated lambda, this is 5. Now let us try to calculate nu. And for calculating nu, uh, we can equate either delta 1 to 0 or delta 2 or delta 3. Any one we can equate to 0. So maybe we can equate delta 3 to 0, right? Because in that way we'll get rid of this third column. So if I equate delta 3 to 0, first row, this will be 2, 7, 12. Then we have 3, 3 and 3. And the third column will be 8, 9. Right, C3, that will be replaced by these constant on right hand side. So 9, 8, and then 16 minus nu. This will be delta 3. So 9, 8, and then 16 minus nu, and this must be 0. So again, you can do the same sequence of a step. You can create two zeros, and then you can calculate nu from here. After calculation, you will find that value of nu, this is 9, right? So that means the point lambda nu, that will be 5, 9. We need the radius of circle which is just touching this line. That means this line is the tangent line. So the radius of circle, that will be 4 into, when the line is 4x minus 3y equals to 0. So 4 into lambda minus 3 into nu, magnitude of this thing, and that divided by in denominator root over a square plus b square. Right, that is standard formula for finding distance of a point from a line. So in denominator we have 4 square plus minus 3 square, and obviously in numerator we need to take modulus of this thing. So clearly you can see that this will be 20 minus 27, so that is 7, and 4 square root of this thing, right? Root over a square plus b square. So after calculating this, you will get 7, and 4 square plus 3 square root will be 5. So that should be the radius of circle, 7 by 5. Right? This was not a difficult problem. I mean, using the condition for infinitely many solution, the condition is delta 0, and then delta 1, delta 2, and delta 3, those three are also 0. So delta 1, delta 0, from there we got lambda as 5. and then delta 3 0. So from there we calculated the value of nu, right? Lambda was 5 and nu will be 9. So therefore the center of the circle will be at 0.59, and then we need the radius of circle. So that is nothing but distance of this line 4x minus 3y equals to 0 from the point 59. That distance is 7 by 5. So therefore the correct answer for this problem is first option. If alpha, beta, gamma are the real roots of this cubic equation, it is given that A, B, C belongs to R and A and B, these two are non-zero. If this system of linear equation in U, V, W, we have a system of linear equation in U, V, W, and as you can see that right hand side is 0, which means we have homogeneous system of linear equation. So if this system of linear equation has non-trivial solution, right? For homogeneous system of linear equation, one of the solution is all the three variables are 0, and non-trivial solution means at least one of those three is non-zero, right? So if this system of linear equation has non-trivial solution, then we have to find the value of a square by b. Now this is one very interesting problem from JEE Main 2021. First we'll see using the condition for non-trivial solution, we'll try to find relation between alpha, beta, gamma, and then those three numbers are the root of this cubic equation. So from there we have to get a, a relation between a square by b. Ultimately we have to find a square by b. So we know that for non-trivial solution, the condition is that determinant of coefficient matrix must be 0, right? Delta must be 0 for non-trivial solution of a system of linear equation, right? Now here if I equate the data, remember system of linear equation is in U, V, W. So alpha, beta, gamma, they are constant. They are the coefficients of U, V, W. So if this system of linear equation has non-trivial solution, then determinant of coefficient matrix that must be 0. That means alpha, beta, gamma, and then beta, gamma, alpha, and then finally gamma, alpha, and beta. This will be the determinant of coefficient matrix, and this has to be 0. Now here if you notice, this is a cyclic determinant, right? In case of cyclic determinant, we have these terms. You have alpha, beta, gamma, then next row is beta, gamma, alpha, and then gamma, alpha, beta. So this is one standard determinant, right? If you expand this determinant, you will get the value as alpha cube plus beta cube plus gamma cube and then minus 3 alpha, beta, gamma, right? And this has to be 0. Now, using the formula for a cube plus b cube plus a cube minus 3abc, this we can write as alpha plus beta plus gamma, and this multiplied by alpha square plus beta square plus gamma square minus alpha beta minus beta gamma minus gamma alpha, and this must be 0. Now, there are two factors here. One is alpha plus beta plus gamma, and the other one is this uh, quadratic factor in alpha, beta, and gamma, right? Now, if product of these two is 0, then there are two possibility. Either alpha plus beta plus gamma will be 0. This is one possibility. Or another possibility will be that the second term is 0, which means alpha square plus beta square plus gamma square minus alpha beta minus beta gamma minus gamma alpha. This should be 0. Now remember here it is given that alpha, beta, gamma, they are the real roots. This word real is important here because in basic maths we learned this concept that if we have three numbers, right, three variables which are real numbers, and if a square plus b square plus c square minus ab minus bc minus ca, this is 0, then this one is possible only when all of these three variables are equal, right? Alpha, beta, because this you can write as perfect square, right? If you talk about the second term, so I'll just write the formula for the second one. This becomes half of, and then you have alpha minus beta square, right? The second term, this is half of alpha minus beta square, then beta minus gamma square, and then gamma minus alpha square. And if this thing is 0, and alpha, beta, and gamma are real numbers, so that means each one of these three values must be 0, right? If we have three perfect square, so perfect square cannot be negative, right? It will be either positive or 0. And if their sum is 0, then each one of these three terms must be individually 0, which means alpha and beta are equal and beta and gamma are equal, right? So from here, you can remember this as standard result that the cyclic determinant is 0 if alpha plus beta plus gamma is 0 or alpha, beta, gamma, all of these three variables are equal, right? This is one standard result that you can remember for cyclic determinant. Now notice here that alpha, beta and gamma, they are the roots of this cubic equation. So if I apply the formula for uh, sum of roots, so alpha plus beta plus gamma, and this must be minus a by 1, right? Minus coefficient of x square by coefficient of x cube. So this must be minus a, and it is given that a and b, these two are non-zero, right? That means we cannot have the first possibility, right? For non-trivial solution, the cyclic determinant will be 0. If this one is 0, then either alpha plus beta plus gamma is 0 or all of these three, they are equal. Now, in this quadratic equation, sum of the three roots will be minus a, and because it is given that a and b are non-zero, so we cannot have alpha plus beta plus gamma 0, which means all of these three must be equal. So from here, if beta and gamma are same as alpha, you can say that a must be minus 3 alpha. So this is the value of a in terms of alpha. A has to be minus 3 alpha. And now here if I use uh, alpha into beta, right? Sum of product of root taken two at a time. So alpha beta plus beta gamma plus gamma alpha. So this must be b by coefficient of x cube, right? Coefficient of x by coefficient of x cube. So this must be b. And because it is given that alpha, beta, and gamma, these three are same. So each one of these three terms will be alpha square. That means b has to be 3 alpha square. Right. So now a is minus 3 alpha and b is 3 alpha square. We have to find a square by b. Right. So just substitute the value here. A square means we have 9 alpha square and b means 3 alpha square. Alpha square you can cancel. Ultimately you will get 9 by 3, which is 3. So the correct answer for this problem will be option B. Right. So in this problem, using the condition for non-trivial solution, delta will be 0. Right. For homogeneous system of linear equation, for non-trivial solution, delta must be 0. And delta was the cyclic determinant. The cyclic determinant is 0 only when alpha plus beta plus gamma is 0 or alpha beta gamma, all of these three are same. Now because alpha plus beta plus gamma is minus a, right, using the relation between roots and coefficient of this cubic equation, and it is given that a and b, these two are non-zero, so therefore alpha plus beta plus gamma cannot be 0. That means all the three roots must be equal. From there we got a as minus 3 alpha, b as 3 alpha square, a square by b, that will be 9 alpha square by 3 alpha square. So finally the correct answer for this problem will be option B. Consider the system of linear equation. We have three equations in three variables, and in third equation there are two unknowns lambda and nu. Right, first two equations are given, and in equation 3 there are two unknowns lambda and nu. These two are real numbers. If this system of linear equation has infinitely many solutions, then we have to find the number of solution of this system of linear equation satisfying this condition that x plus y plus z, this is between 7 and 77, and x, y, z are integers. Now, the general method of solving this problem is to find the value of lambda and nu using the condition that this system of linear equation, this has infinitely many solutions. We know that for infinitely many solutions, the condition is delta is 0, that is determinant of coefficient matrix is 0. So from there you will get the value of lambda, and then delta 1, delta 2 and delta 3, these three are also 0. This is the condition for infinitely many solutions, right? But if you are familiar with the basics of system of linear equation and their condition for consistency and so on, then there is no need to find lambda and nu from here, right? If this system of linear equation has infinitely many solutions, then this third equation is not any independent equation. Equation 3, or in 3D, three equations in equations in XYZ, linear equations in XYZ in 3D, that is equation of plane. So if we have infinite number of solutions or infinitely many solutions for this system of linear equation, then basically this third plane, this is passing through the line of intersection of first two planes. So therefore, this third equation will not give us any independent information, right? Equation 3 will be some combination of equation 1 and 2. So here basically we need to focus on equation 1 and 2. From here, try to find values of any two variable in terms of third variable and then substitute in this equation. For example, you can write x and y in terms of z, or you can write y and z in terms of x, right? Any two variable we have to express in terms of third variable and then substitute that value here. So from there we can see what are the different possibilities, what are the different integral values of these variables which will satisfy this condition, right? So for doing that, let us try solving equation 1 and 2. Let us try to write any one variable in terms of third variable using equation 1 and 2, and there is no need to calculate lambda and nu here. So if I want to eliminate any one variable, let us say if I want to get rid of z, then we can multiply this first equation by 3. That means we can write that 3x plus 5y plus, if we multiply by 3, then 3x plus 15y minus 3z, this will be 3. And the second equation, this is 4x plus 3y minus 3z, this equals to 7. And now we can do 2 minus 1, right? If we do 2 minus 1, then you can see that 4x minus 3x, that will be x. 3y minus 15y, so that is minus 12y. Z will cancel, and 7 minus 3, that will be 4. So from here we can write x in terms of y, right? We can write x as 12y plus 4. Our aim is to express any one variable in terms of other two variable. We got x in terms of y. X is 12y plus 4. Now substitute that value in any one of these two equations. Let us say first equation. So in place of x, I'm writing 12y plus 4 and then plus 5y minus z, this is 1. That means from here we'll get z in terms of y. In fact, z will be 12 plus 5, that is 17y, and 4 minus 1, 3. So this is the value of z in terms of y, right? So we got x in terms of y, we got z in terms of y, and now the given relation is that x plus y plus z, this is between 7 and 77. So that means x is 12y plus 4, then y, and in place of z we have 17y plus 3, and this should be between 7 and 77. And now let us see how many integral values of y are possible from here. So 7 we can remove, so then we have in 4 plus 3, that will be 7, and then 17 plus 1, 18 plus 12, right? Maybe we can write few more lines here. So 7, and here we have 30y plus 7, and the right hand side, this is 77. Now subtract 7 from here, so then we have 30y, this is between 0 and 70. So from here clearly you can see that the integral values of y, because it is given that x, y, z, they are integers only. So you can take y as 0, or you can take 1 or 2, right? If I take y as 3, then it will not satisfy this inequality. So these are the three possible values of y. And corresponding to these values of y, you will get values of x from here and values of z from this relation, that z was 17y plus 3. So basically, these are the three integral values of y, 0, 1 and 2. And each integral value of y will give us some value of x from here and some value of y from here. The problem was that we need to find number of solution of this system of linear equations satisfying the given condition. So there are three integral solutions, y 0, 1 and 2, and then x and z we can calculate. We do not need the exact solution, we need number of solution. So there are three solutions, right? So therefore the correct answer for this problem will be option C. Now in most of the solutions you will find that they will first try to calculate lambda and nu using these conditions for infinitely many solutions. but there is no need to calculate those things. You can directly start with equation 1 and 2, because if we have infinite number of solutions, then this plane 3, this is passing through line of intersection of plane 1 and 2, and that will mean that plane 3 will not give us any independent equation, right? It will be some combination of equation 1 and 2. So we can solve 1 and 2 using equation 1 and 2, write any one variable in terms of third variable. Here we have expressed x and z in terms of y, and then substitute in this equation, right? So from there we got three integral values of y, and hence the number of solution for this system of linear equation under the given condition, that will be 3.